Hello, I am Sunita. Welcome to my class. Here I am going to discuss Karnataka DIT science topics according to the syllabus. Here I am going to discuss in detail magnetism. The topic is magnetism. First one, let us see what is meant by a magnet. A magnetic is a material that produces a field that attract or repel other such materials of magnetic nature. A magnet is a material that it will produce a field, then that because of that field it will attract some of the object, it will repel some of the object of having that objects they will having some magnetic nature. Only the magnet it will attract the objects having magnetic nature. Almost all the metals they will be attracted by the magnet. Lodestone is a naturally occurring magnet. It attracts materials like iron, nickel, cobalt, etc. Already I told almost all the metals they will be attracted by the magnet. Here you can observe in a magnet you are having two poles. One is north pole, another one is south pole. When you are having different poles like south pole and north pole, they will be attracted by each other. If you are having same poles like south pole or north pole, then they will repel each other. From this you can conclude same poles they will repel each other, unlike poles they will attract each other. This is the law of magnetism. North pole and south pole. When you are consider a magnet it is having two poles. One is north pole, another one is south pole. A magnet is always bipolar with poles named south pole and north pole and south pole. Bipolar means two poles. Magnet is always having a bipolar means two poles. One is north pole, another one is south pole. These two poles always exist together means always if you consider a magnet, if you consider any bigger magnet or small magnet, even small magnet also you can identify two poles. Even a single piece of small piece of magnet also you can identify two poles. Otherwise two poles it will exist even in small piece of a magnet and cannot be separated. Already I told in a small piece of a magnet also you can exist, you can observe two poles. One is north pole, another one is south pole. These poles you can't separate. Even if you break also, even if you cut the magnet also, in that small piece also you can identify north pole and south pole. Therefore you can't separate north pole and south pole in a magnet. North pole of a magnet is the side which points to earth geographic north when it is freely suspended. When you freely suspended the magnet, then it will north pole of the magnet it will point towards the earth geographic north, and south pole of the magnet it will point towards the earth geographic south. When you freely suspend the magnet it will show north south direction. Next one, like poles repel and unlike poles attract. Similar to charges, poles attract and repel. Like poles repel while unlike poles attract each other. Here you know the magnet it is having two poles. One is north pole, another one is south pole. Like poles means south pole, north poles they will repel each other. Like poles they will repel each other. Unlike poles like south north or north south they will be attracted each other. This is nothing but law of magnetism. Bar magnet. A bar magnet is a rectangular object. Here you can observe a bar magnet is a rectangular object composed of iron, steel or any form of a ferromagnetic substance. Bar magnet is made up of a iron or steel or any form of a ferromagnetic substance that shows permanent magnetic properties. The bar magnet it will show the permanent magnetic properties. And here in the bar magnet it has two poles. One is a north pole, another one is a south pole. North and a south pole such that when suspended freely the north pole align itself towards the geographic north of the earth. If you suspend freely the bar magnet, north pole of the bar magnet it will point towards the earth geographic north, and south pole of the bar magnet it will point towards the geographic south pole of the earth. The next one, magnetic field, the reason around a magnet where its magnetic influence can be experienced is called as a magnetic field. This is the reason where we are experiencing a magnetic field. That one we will call it as a magnetic field. The direction and strength of a magnetic field are represented by the magnetic field lines. The direction or strength of a magnetic field is represented by a magnetic field lines. Let us discuss in the next slide in detail. Iron filing test around a bar magnet. This experiment, it will show in a particular magnet, it will show a magnetic field. Then how magnetic lines they will be arranged with the help of the magnetic field. With the help of this iron filings, we will come to know the direction of a magnetic field lines, otherwise pattern of a magnetic field lines. Iron filings around a bar magnet exhibit the magnetic field lines that encircle the bar magnet. The magnetic field lines can be explained as an imaginary line that graphically represent the magnetic field that is acting around any magnetic substance. These are the magnetic lines. These are the imaginary lines you can't see with the help of your eye. These are the imaginary lines that graphically represent the magnetic field lines that is acting around any magnetic substance. The magnetic field, it will created around a magnet, particular magnet. Then it will decide the strength of a particular magnet. Let us discuss the experiment. Take a bar magnet on the white paper and keep the bar magnet on the white paper. Then sprinkle iron filings on the bar magnet. Then tap the white paper slowly. When you started tapping, then you can see the arrangement of iron filings around a bar magnet. Then after some time, you can observe a particular pattern of magnetic field lines around a bar magnet. This it will show the indication of direction of magnetic field lines around a bar magnet, and it will show the strength of a bar magnet also. From this experiment, you can conclude the direction of magnetic field lines, otherwise pattern of magnetic field lines, easily. With your experiment, you can observe the pattern. From iron feeling experiment, we got the pattern of an magnetic field lines around a bar magnet. Let us discuss the feature of an magnetic field lines. First one, magnets. Magnetic field lines result in the formation of a continuous or running closed loop. You can observe from this figure, the magnetic field lines, they will generate it at one pole and they will reach at the another pole. The generating point is north pole and it will reach at the south pole, and the magnetic field lines, they will form a pattern of a closed loop. You can observe a closed loop. You can't see any disconnection between the poles. Then here the magnetic field lines, they will be generated from north pole, then they will reach south pole and they will follow a closed loops. Second one, the tangent to the field line at any given point indicate the direction of total magnetic field at that point. The tangent to the field, it will show at any particular point, it will indicate the direction of total magnetic field at that point. The greater the number of field lines crossing per unit area, the higher the intensity, the stronger the magnitude of magnetic field. If here you can observe the magnetic field line generated from north pole and they will reach at south pole. If you are having more number of magnetic field lines in a particular area, then it will show the intensity of magnetic field, and also it will show the stronger the magnitude of magnetic field. If you are having more number of magnetic lines per unit area, then that particular magnet, it will produce a more magnetic field. Therefore the magnetic field, otherwise magnetic field strength, it is defined, it depends upon the number of magnetic field lines per unit area. If we are having more number of magnetic field lines, then it will show the more strength of an magnetic field in a particular around a particular magnet. Last one, there is no intersection between the magnetic field lines. Here you can observe, here the magnetic field lines, they will follow a closed loop, and you can observe here any two magnetic field lines, they will not intersect each other at any point. They will not able to intersect, otherwise they will not intersect at any one particular point. Then here from north pole, here the magnetic at the poles, the magnetic field lines, they will get diverged, they will come out from the north pole. Here also south pole. Then here in the case of a north pole, the magnetic field lines, they will come out from the north pole. It will show this direction. But in the case of a south pole, the magnetic field lines, they will enter into the south pole. One more thing you can observe here, at the pole the magnetic field strength, it will be more compared to this closed loop. At the poles the magnetic field length, it will be more. This point is very important, this one you have to remember. Then listen here, the magnetic field lines, they will generated at the north pole, then they will reach at the south pole in a closed loop, then tangent to the point at any point in the magnetic field, it will indicate the total magnetic field strength at any point. Then here if you are observe a more number of magnetic field lines per unit area, then it will show the strength of a particular magnet, and there is no intersection between the magnetic field lines. Whenever you can identify in this pattern, there is no intersection of magnetic field lines, it will takes place. Magnetic field due to a current carrying and conductor. Let us verify this one with an experiment. That is nothing but a boosted experiment. Here this is the experimental setup. You are having a battery, switch, this is the conducting wire, this is the magnetic needle. Here when the switch is off position, then there is no generation of the current, then there is no generation of a magnetic field. Then here the magnetic needle, it will not get deflected. If you switch on, then the current, it will flow in one direction to the another. Here this is the direction of an current. Then here when the current flows in a conducting wire, then it will generate a magnetic field. Because of the generation of magnetic field, this magnetic needle, then it will show the deflection. Then here one more important point, if you are generating more current in a particular conducting wire, then it will produce more magnetic field. Then this magnetic needle, it will show more deflection. Then the deflection of the magnetic needle, it will be more if you are having more magnetic field. Then here consider in this case, this is the direction of an electric current. Then the direction of magnetic field, it will show in this direction. If you reverse the direction of an electric current from this direction, then you can observe the magnetic needle also, it will change its direction. This is also very important point you have to remember. The deflection of an magnetic needle, it will indicate the generation of an magnetic field when a current carrying in a particular conducting wire or conducting material. Here Worsted experiment, when electric current flows through a current carrying conductor, it produces a magnetic field around it. This can be seen with the help of a magnetic needle which shows deflection. Already I told the magnetic needle, it will show the deflection. This, it will indicate the generation of a magnetic field. The more the current, the higher the deflection. If more current, if it is flows through a conducting wire, then this magnetic needle, it will get deflected more. If the direction of current is reversed, the direction of deflection is also reversed. Compare these two figure, you can observe here this is the direction of the current, and here the direction of magnetic field, it will show in this direction. Then here the direction of the electric current is show in this direction. Then you can observe the direction of magnetic field here. If the direction of current is reversed, the direction of deflection is also, it will get reversed. Then from this Worsted experiment, you can conclude when a current carrying conductor, it will produce as a magnetic field. Electromagnetism and electromagnet. Here consider this experimental setup. Consider an iron nail. Wind the iron nail with copper wire. Iron and copper, they are good conductor of electricity. That's why we are using here iron nail and copper. Then here this is the key. This is the battery. Here this one is in the key is in switch off position. When the key is in switch off position, there is no flow of current, then there is no generation of magnetic field, and here you can't observe any electromagnetic field. But here when your switch is in on position, then it will generate a current, and this is the direction of an current. From this direction to this direction it will flow. When current generate, otherwise when current flows in a flows through a copper wire, then it will create a magnetic field around a iron nail. Then this iron nail, it will start behaving as a magnet. Because of this property, it will generate a magnetic field around a iron nail. Here you can observe, this is the north pole of the magnet, this is the south pole of the magnet. Then magnetic field lines, they will come from north pole to south pole in the form of a closed loop. Then this it will show the direction of a magnetic field here. Then this, when the current is continuously flowing in this iron nail, then this iron nail continuously it will produce as a magnetic field. But when the current is switch off, then when it is disconnected, then this iron nail, it will stop behaving as a magnetic field, and there is no generation of magnetic field. And this iron nail, it will not behave as a magnet, it will behave as a ordinary metal. Let us see here electromagnetism and electromagnet. An electromagnet is an artificial magnet which produces a magnetic field on the passage of electric current through a conductor. When electricity is passed through a conductor, then it will produce a magnetic field. This field disappears when the current is turned off. Already I told, when the current is turned off, then this magnetic field, it will get disappear. This phenomenon of producing or inducing a magnetic field due to the passage of electric current is called as a electromagnetism. What is mean by electromagnetism? Electromagnetism is nothing but producing or inducing a magnetic field due to the passing of an electric current. This phenomenon we will call it as a electromagnetism. Here when the battery is in when switch on position, then this it will generate a current. Then this current it will induce a magnetic property of a iron. Then it will produce a magnetic field around a iron nail. But when you disconnect the current, then this iron nail, it will not behave as a magnet, then it will not generate a magnetic field. Therefore this iron nail here, it temporarily it will behave as a magnet. It will not become a permanent magnet. This one we will call it as a electromagnetism or electromagnet. Magnetic field due to a straight current carrying conductor. This is the straight conductor. When current passes through a straight conductor, then it will produce a magnetic field around it. Let us verify this one. This is the straight conductor. Take straight conductor in the center of the paper and put iron filings on the paper. Then if current passes through this straight conductor, then because of the magnetic field, the iron filings, they will be arranged in the form of a concentric circles. Then what is mean by a concentric circles? The circles we are getting from the same center but having different radii, that we will call it as a concentric circles. When a current is passed through a straight conductor carrying conductor, then a magnetic field is produced around it using the iron filings. We can observe that they align themselves in the concentric circles around the conductor. Here, this formation of a concentric circles, it will indicate the presence of a magnetic field. Right hand thumb rule. If a straight conductor is held in the right hand in such a way that the thumb points along the direction of the current and the tip of the fingers or curl of the fingers shows the direction of magnetic field. If you hold the straight conductor, current carrying conductor at the right hand, then this thumb direction, it will show the direction of the current, and this tip of the fingers, it will show the direction of an magnetic field. Here, using right hand thumb rule, we can identify the direction of the current and direction of the magnetic field. Magnetic field due to a current carrying through a circular loop. This is the circular loop. When current passes through a circular loop, then it will also create a magnetic field around the loop. This is the direction of the current. This is the direction of the magnetic field. The right hand thumb rule can be used for circular conducting wire, as well as it comprises of small straight segments. In the case of a circular loop also, we can use right hand thumb rule. If you hold a circular loop in right hand, then the direction of the thumb, it will indicate the direction of the current. Then tip of the remaining fingers, it will show the direction of a magnetic field. Every point on the wire carrying current gives rise to a magnetic field that appears as a straight line at the center. Each and every point in the current carrying conductor, it will produce a magnetic field. Then it will appear as a straight line at the center. Magnetic field due to current in a solenoid. A solenoid is a coil of many circular windings wrapped in the shape of a cylinder. Here, the solenoid is made up of a coil of many circular windings wrapped in the shape of a cylinder. The solenoid, it should be in the shape of a cylinder. When current is passed through it, it behaves similar to a bar magnet. The magnetic field, it will follow a same pattern in the case of a solenoid. It is same as in the case of a bar magnet, producing a very similar field pattern as that of a bar magnet. To increase the strength of a solenoid, we will use soft iron core is used. To increase the strength of a solenoid, then this coil, it should be made up of a soft iron. If you use soft iron, then it will produce a more magnetic field. Then magnetic field line strength will be more if you use a soft iron. Then here, pattern of magnetic field lines is same in the case of a bar magnet. Thanks for listening my class. Send me your valuable feedback. Thank you.